Another type of quasi-experimental design, or at least not a true experimental design, is a single case experimental design. I rarely run across these in my field of work. But let's start by asking, what does a single case mean? You might remember that from your prior knowledge of other classes. Well, a single case usually means one person or one entity is observed over time. So it can mean one group is observed over time. Like if you're studying your own department at work as a research study, that would be a single case. Also, Freud studied individuals, so he published works on a single person, a single case. Now remember, we're talking about experimental design. So there's going to be some sort of manipulation going on, some sort of treatment or event when we talk about this. So one example might be if a child seems hyperactive and needs help, there might be a plan that's drawn up to manipulate or at least to give some sort of treatment to the child over a certain amount of time and then observe whether the child gets better. So maybe the hyperactive child is given, let's say, a diet with healthy foods, protein and vegetables, no junk food, daily exercise, naps, appropriate bedtime, and a therapist to help with a certain kind of treatment. And let's say that goes on for a few weeks, and then they observe whether there's improvements, and then maybe there's a few weeks when it doesn't happen, improvement. But there's different ways to do it. But the idea is that there's one person, there's some treatment that's given, and an observation. By the way, a lot of psychology majors go on to do work that relates to this type of design. So they don't really necessarily do research, but they go into homes where a child has maybe some developmental disorder and needs some extra help, and they become the therapist to the child, and they'll go regularly, let's say once a week at the same time, and they will administer a treatment. They will work with the child to help them with what they need, and they observe the improvement. So I think Easter Seals is a company that I've seen my alumni, a lot of students that I knew who become alumni go to work for. Feel free to ask a professor if you want more information about that, and you might be interested in that. It's somewhat easier than other jobs to get, and something that a lot of students do appreciate when they graduate, getting such a job. Correlational designs, as I mentioned, they're sometimes called a category of quasi-experimental, but really most of us don't talk about it that way. If you're doing a study and writing it up for a class and you've done a correlational study, please don't call it a quasi-experimental design. It'll just be really more correct, or what most of us say, I should say, to call it correlational design. Because we use the word quasi-experiment, but not really to talk about a correlational design. Okay. So the author of some of the classes I teach, there's an author of the textbook Rosenthal and Ray, and I mentioned that they kind of use it in this way. So you might want to review what you've learned about correlational research and be prepared to think about it when you're thinking about these topics. Often in my classes I will talk about it early in week 1 so that people have a basic reminder of it before we get into other topics. So remember, correlation does not imply causality. It does not imply causation. So that's one of the major limitations with correlational research, is that we just don't know what causes what. We don't know if what we think might be the cause of something is actually causing it. We just know whether two variables are associated, whether as one increases, another increases, stays the same, or decreases. Oftentimes, a correlational study, that's basically the definition, actually includes a correlational statistical analysis. The analysis is conducted with two variables and produces a number that shows, or value, the extent to which an association exists between those two variables. That's the R value. So the R value, or we call it correlation coefficient. So think about as ice cream sales increase, so does crime. That's a correlation. That we know how much ice cream is sold, say in the US, and we know how much crime specifically, like burglaries, occurs, and we know that as one goes up, the other also goes up. I've heard students tell me that ice cream sales are related to shark attacks. So I'd like to check that out. I think that those both that might be true relationships, because we know as ice cream sales increase, crime does because of weather and temperature, and I would imagine it would be the same for shark attacks. A less uh, exciting or kind of sad example, age and height in children. That's a nice benign example. As age increases, height increases, at least through adolescence, right? So let's say a 4-year-old might weigh 40 pounds and be 3 feet tall. Let's say like a 9-year-old might be 50 pounds and 4 feet tall. As age and height increase, they both increase. Okay, so they're correlated. I believe there's some GPA and SAT score correlations. We could check that research that says as GPA increases, SAT scores increase, but it's not exact. But the reason I'm mentioning that there might be that is because I made up some data here to remind you about correlations. So I made up these names of people, and I made up an SAT score for them, and I made up a GPA. I find it's very helpful when you're learning statistics to make up data, because to make it up, you have to kind of be thinking about what the statistics you want to do, what it means, and get a good example. So here we see there's a few people, Bob, Kevin, Neil, Ben. These happen to be guys that have very low SAT scores. They're in the 700s. Their GPA is also low, 2.2. Then I made up a female who also has a low one, and a male who has a kind of low one. Then I made up some names of females with high SAT scores and high GPAs, 4.0, 4.0, 4.0. So I know that this should create a positive correlation. So I did run this in SPSS. I made a scatter plot. Each of these dots represents someone in the study. I may have added a couple before doing that, but you can kind of have a sense of what it looks like here. And this is what the SPSS output looks like. SAT score is associated with GPA in junior high, according to this. And the R value is 0.99, so that's a very high. I never get such high correlations in my work, a very high correlation. And it's less than 0.05, the p-value or significance is less than 0.05. So this just gives you a brief reminder of what an SPSS output looks like when you do correlational analysis. If you're doing it for your class, you might find it helpful to see this. Let's talk about longitudinal designs. This is a design in which the same individuals are observed or tested repeatedly at different points in their lives. In other words, researchers make observations of key characteristics of one group of participants over a long period of time. And the same group of people are followed sometimes for years. So this is a within subjects study because you follow the same people and see how they change over time. Now, often young participants are followed for many years. There's a classic study by Dr. Terman, who ran a study of gifted youth, and he followed the youth throughout their lives. He did work over much of his life, and in fact his colleagues continued the research after he died. And this is pretty amazing data. I think it was eight decades long, from 1921 to 2001. And I've heard that there's researchers who are continuing to update it, and they will find out what participants have died and from what cause, and they'll update the data. So I believe there's a researcher named Dr. Howard Friedman at UC Riverside who does this kind of work, in case you're interested. And you can look up some of his work. I believe he looks at factors and mediators that predict living longer and healthier lives. So in this kind of work, you can do questions. You can ask questions about aggression or personality and find out whether they're consistent from childhood through adulthood. Find out what helps people be healthier. There's a lot of things we use longitudinal design for. There's a video called the 7-Up series, and I believe it's a BBC or British public broadcasting documentary. The group of children were followed at 7-year intervals starting at age 7. They're filmed at age 7 and 14, 21 years of age, 28 years of age, 35 years of age, 42 years of age, and so on. In the show, you can see a variety of results. You can see what the personality of the children is. In the documentary, you can see sort of which child was very aggressive and what type of job he has that is appropriate for someone who's aggressive, and what kind of Other child is very calm, very intellectual, very thinking, very much a thinker, and how her future job also relies on and needs those kinds of skills. And they are interested in socioeconomic status and how that plays out over time, and you'll see some of that in the series as well. Cross-sectional designs are often contrasted with longitudinal. In a cross-sectional design, and they're both observational, we might say that it's a type of observational study that analyzes data collected from a population or representative subset at a specific point in time, and that gives cross-sectional data. Maybe an easier way to say it is that several groups of people are studied at one time. Usually different categories of ages are chosen. So let's say 20 people are recruited and their age, I don't know, 1 to 5. Then another 20 people are recruited and they're 6 to 10, and another 20 are recruited who are age 7 to 15. Another group of people are 16 to 20. So you study them basically all at one time. And by the way, one time does not mean you observe them literally at the exact same time. It can mean over a span of a few months that you are observing people. But you only observe each person once, and it's a between subjects design. You compare the scores of different groups. Let's think of an example. Imagine that you hear someone who's 70 years old say something that you consider to be racist or sexist or prejudiced, show some sort of prejudice. And you decide you want to learn more about this. Let's say you focus on sexism and you want to know, do people get more sexist? Are you more likely to get more sexist as you age? Well, you could do a cross-sectional study. You could take 20-year-olds and a bunch of 70-year-olds, let's say 100 of each of them, and you could see, are the 70-year-olds indeed more sexist than the 20-year-olds? You could ask questions like, women cry too much, men should never cry, men should never change a diaper, men are good at sports, women are not, things like that. And you could see, how do they answer differently in these different age groups? I wonder if you can think about what you might find. Well, you're probably going to find that the 20-year-olds today, like in the US, are not going to seem as sexist as 70-year-olds. So a lot of people realize that 70-year-olds are from a different generation. They come from a generation in which there were certain expectations of men and women that are perhaps different than they are today. You know, men weren't expected to raise a child and the woman was. Men were expected to go out of the home and work, and where the woman was expected to stay home and raise a child. She was expected to, say, change the diapers, and it was not okay for a man to want to stay home with his child, but a woman could. So these major generational differences. Now, a problem with this kind of research is I don't think you're going to be able to see, right, that a 20-year-old actually gets more sexist. They just have a different generation. So you might think that there's aging differences, but to really know this, you need to do a longitudinal study to see if 20-year-olds actually do get more racist. As we talk about this, we might want to mention the idea of cohorts. And a cohort is a group of people sharing a given characteristic, usually an age. Now there's actually a lot of slightly different definitions of it, and so you might find that it can mean a group of people banded together. It can mean people treated as a group. It can mean people who have similar experiences and concerns. I know some demographers who say that it really kind of refers to groups who are of the same generation. So a cohort would be a group of people aged 70 to 79, and a cohort can be a group of people aged 20 to 29. They might say a cohort of people aged 70 to 79 were more conservative than the cohort of people aged 20 to 29. And we don't know if there's generational difference or if it's an age difference, but that's it. It's often very confusing I've heard demographers say that it's confusing to them because they have a slightly different definition than people in public health or preventive medicine or health psychology. So it's hard for them to work across disciplinary lines when they don't have the same definition. By the way, I think we have a club on our campus where they referred to the first year that the club started as cohort 1 or generation 1, and then the second year they called those students the cohort 2 or generation 2. I can only imagine how confusing that might be to a demographer who knows that in any club there's going to be people of all ages and they're only a year apart in their age in school. But overall, I think you now have a sense of the differences in a few of these types of correlational design. And we'll move on to something next in the next video.